Hi everyone. So let's discuss about problems behind big data and the solution given by Hadoop. So the first problem is storing the colossal amount of data. So that means storing huge data in traditional system is not possible. So the reason is clear. So the storage will be limited to one system and the data is increasing at tremendous rate. The second problem is storing heterogeneous data. So now we know that storing is a problem. But let me tell you, it is just one part of the problem. So the data is not only huge, but it also present in various formats like unstructured, semi-structured and structured. So you need to make sure that you have a system to store different types of data that is generated from various sources. So finally let's focus on the third problem, so which is processing speed. So now the time taken to process this huge amount of data is quite high, as the data to be processed is too large. So in order to solve this storage issues and processing issues, two core components were created in Hadoop. So one is HDFS, another one is YARN. So HDFS solves the storage issue as it stores the data in the distributed fashion and it is easily scalable. And YARN solves the processing issues by reducing the processing time. So moving ahead, let us understand what actually Hadoop. So Hadoop is an open source software framework used for storing and processing big data in a distributed manner on a large cluster of commodity hardware. Hadoop was developed based on their paper written by Google on MapReduce system, and it applies concept of functional programming. Hadoop is written in Java programming language. So was developed by Doug Cutting and Michael J. Caffarella. So let us understand how Hadoop provides a solution to behind the problem, so that we have discussed so far. So the first problem is storing huge amount of data. As you have seen in the above image, HDFS provides a distributed way to store big data. So your data is stored in blocks and data nodes, and you specify the size of each block. Suppose you have 512 MB of data and you have configured HDFS such that it will create 128 MB of data blocks. Now HDFS will divide data into 4 blocks as 512 divided by 128 equal to 4 and stores it across different data nodes. Actually HDFS Hadoop follows horizontal scaling, so instead of vertical scaling. In horizontal scaling, you can add new nodes to HDFS cluster and the run as per requirement. So instead of increasing the hardware stack present in the each node. So the next problem was storing a variety of data. So as you can see in the above image, in HDFS you can store all kinds of data, whether it is structured, semi-structured or unstructured. So in HDFS there is no pre-dumping schema validation. So it also follows write once and read many models. Due to this, you can just write any kind of data once and you can read it multiple times for finding insights. The third problem challenges was about processing of the data faster. So in order to solve this, we move the processing unit to data instead of moving data to the processing unit. So what does it mean by moving the computation unit to data? So it means that instead of moving the data from different nodes to a single master node for processing, the processing logic is sent to the nodes where the data is stored, so as that each node can process as a part of data in parallel. Finally, all the intermediary output produced by each node is merged together and the final response is sent back to the client. So let's discuss about what are all the features of Hadoop. So one of the main features of Hadoop is reliability. So when machines are working as a single unit, so if one of the machines fails, the another machine will take over the responsibility and work in a reliable and fault tolerant fashion. Yes. Hadoop infrastructure has inbuilt fault tolerance features and hence the Hadoop is highly reliable. So the next feature is economical. So Hadoop uses commodity hardware, so like your PC and laptop. So for example, in a small Hadoop cluster, so all your data nodes can have normal configurations like 8 to 16 GB of RAM with 510 terabytes hard disk and Xeon processors. But if I would like to use the hardware based like RAID with Oracle for the same purpose, so I would end up with spending 5 times more than at least. Yes. So the cost of ownership of Hadoop based project is minimized. So it is easier to maintain a Hadoop environment and is economical as well. So also Hadoop is open source software. So hence there is no license cost. The next feature is scalability. So Hadoop has the inbuilt capability of integrating with cloud-based services. So if you are installing Hadoop on a cloud, you don't need to worry about the scalability factor because you can go ahead and expand your setup within a minute. So whenever and wherever it is required. So the another most important feature is flexibility. So the Hadoop is very flexible in terms of ability to deal with all kinds of data. So whether it is structured or semi-structured or unstructured. Clear? So these are all the 4 characteristics make Hadoop a front runner as a solution to the big data challenges. Now that we know what is Hadoop, we can explore the core components of Hadoop. Let us understand what are all the core components of Hadoop. So while setting up Hadoop cluster, you have an option for choosing lot of services as part of your Hadoop platform. So but there are 2 services which are always mandatory for setting up Hadoop. So one is HDFS and another one is Yarn. So HDFS stands for Hadoop Distributed File System, which is a scalable storage unit of Hadoop. So whereas Yarn is used to process the data, so that is stored in HDFS in a distributed and a parallel fashion. So let us go ahead with HDFS first. So the main components of HDFS are the name node and the data node. Okay. So let us talk about roles and responsibility of these 2 components in detail. Let's talk about name node first. Name node is a master daemon, so that maintains and manages the data nodes, that is slave nodes. It records the metadata of all the blocks of stored in the cluster. So example, location of blocks stored, size of the files, permissions, hierarchy, etc. So it records each and every change that takes place of file system metadata. If a file is declared in HDFS, the name node will immediately records in the edit log. So it regularly receives the heartbeat and the block report from the data nodes in the cluster to ensure that the data nodes are alive. And also it keeps a record of all the blocks in HDFS and data node. It has a high availability and federation features. Okay, so that will be discussed in later part of the session. So the another next data node. So the data node is a slave daemon, so which runs on each slave machines. The actual data is stored on these data nodes only. So it is the responsible for serving read and write requests from the clients. It also responsible for creating blocks, deleting blocks, and replicating the same based on the decision taken by the name node. It sends heartbeats to the name node periodically to report the overall health of the HDFS by default. So this frequency is set to 3 seconds. So this was all about HDFS in a nutshell. So now let's move ahead to our second fundamental unit of Hadoop. So that is Yarn. So Yarn comprises of 2 major components. So one is resource manager, another one is node manager. But actually resource manager, so resource manager is a cluster level component and runs on the master machine. So it manages resources and schedules applications running on top of it. Basically, it has two components. So one is scheduler, another one is application manager. So the scheduler is responsible for allocating resources to the various running applications. The application manager is responsible for accepting job submission and negotiating the first container for executing the application. So resource manager also keeps the track of heartbeats from the node manager. The next node manager, so it is the node level component and runs on each slave machines. So it is the responsible for managing containers and monitoring resource utilization each container. So it also keeps track of node health and log management. So this node manager is also continuously communicates with resource manager to remain up to date. So that's all about core components of Hadoop. So next lesson will be about Hadoop ecosystem. Thank you.